let us discuss about the motional EMF. The motional EMF is the EMF induced or the current induced in a coil when one side of the coil is moved with a velocity. When one side of a coil is moved with a velocity, what we are increasing? We are increasing the flux that is passing through it. Firstly, if we have a coil PQRS and this PQ side of that coil can be slided over. So what we are doing, we are changing the length from x to x plus dx. So when we change the length by dx, that means the flux passing through it changes. When the flux passing through it changes, that means the EMF is induced in the coil. As we know that EMF is equal to minus d phi b divided by dt, that is rate of change of magnetic flux that is passing through it induces the EMF in it. Now we know that flux is phi b is ba cos of theta, or phi b is b dot a. Now in order to change the flux, we can increase or decrease the magnetic field intensity. Number 2, we can increase or decrease the area. Number 3, we can change the orientation of the coil with respect to the magnetic field. In that case also, the magnetic flux linked with that coil changes. Now, what we are doing here, we are changing the area. So there is change in flux. d phi b is equal to b dot da or bda, as theta is equal to 0 between the magnetic field and the area vector. B dot dA. So the EMF is equal to minus B dot dA divided by dt. Now dA here, in this case, the area dA will be equal to, what is the breadth? L. What is the increase in length? dx. So dA is equal to L dx. This is not the area, this is the change in area by sliding of this PQ with velocity v. So we have that E is equal to minus B L dx divided by dt. Now we have minus b L into v because velocity is rate of change of displacement, that is dx by dt. Now taking the magnitude only, E is equal to BLV. So EMF is induced in the coil by the motion of this PQ side. So it is called as the motional EMF. So motional EMF is equal to BL into V. So if the B is constant, L is constant, so the motional EMF depends upon the velocity. If the change in velocity or the velocity is more, EMF is more. If the velocity is less, EMF is less. When the velocity is more, the rate of change of flux will be more, so the EMF is more. When the velocity is less, rate of change of flux will be less, so the EMF is less. If we go for the induced current I will be equal to E by R, that will be equal to BLV divided by R. Now we know that when a current carrying conductor is placed in a magnetic field, it experiences a force, and that force is equal to F, and that is equal to ILB. Force is equal to I into L into B. Now we also know that power is equal to F into V. Power is equal to F into V. So here we have force is ILB into V. Taking the value of current from here, we have got P is equal to BLV divided by R into BLV. That is equal to B square L square V square divided by R. That is the power that is required to slide the PQ in this direction. From the study of electric current, we know that power is equal to I square into R. So power is equal to, taking the value of I from here, we have BLV divided by R whole square into R. That P is equal to B square L square V square divided by R square into R. This R and R gets cancelled. Here we have got also P is equal to B square L square V square divided by R. This is just the beauty of the physics. From wherever you will start, you will end at the same results. Thank you.